We're just going to get started. Thank you everybody for joining us today. This is part 3 tutorial for our new users for Sketchulation. Sketchulation is a tool that we use in our office, tipping, which is a 38-person firm in downtown Berkeley. I have been with tipping for about 7 years. I'm a structural engineer. I'm also helping with some business development for the company. Joining us today is Mike Horolik, who is one of our principals. Mike has been with the firm for about 19 years, and he actually is not only the developer behind Sketchulation, but he's also very involved in some of our intense projects. He's an expert on nonlinear analysis. So I'm going to flip to the next slide. Today, we're going to be talking about fiber section analysis. We're going to be working on a concrete section and executing some fiber section analysis and exposing you to how to read the results. In the second part, we're going to be plotting a chart from table of data and also answering a specific question from one of our tutorial attendees. We're also going to do a little bit of a review of part 2, which was a session that we held 2 weeks ago. So I'm going to hand it over to Mike. The screen sharing will be on his side. But these are the things we're going to be covering. You can also reference some of the notes that I shared with you, I believe, yesterday. So.
Okay. I'll take over here. Share. Alrighty. Thanks, Natalie. So we just did the part 2 tutorial yesterday, and I just brought up this file that I had been working on yesterday as a review of what we had done. So this was a way up. If you remember, we drew our shapes here in plan, overlaid them on an image. We talked about creating layers and separating out the different components of our way up by layer. And we talked about how you make a boundary around all of the entities with their weight assignments, and then you give that boundary a tag, and then you use the entWeight function to calculate the weight of that composite. Yesterday, when I went over this with the other group, I showed how you could do this for 2 different floor levels. So in this floor level, we had something that was called shape boundary, or ship BDY. And then we had a second floor that we drew up very quickly and just removed a couple of things as an example. And we gave that a slightly different tag, called that underscore LO2 for the second level. And then I showed you could basically get the weight for both of those floors using the table functionality. Now, I did want to respond to a question from Mohammed about how do you deal with openings or holes and I think that was related to the way up. So this is how we would do that. So right now I have a shape that represents the floor area. And the program thinks it's a solid shape with no holes. But if you had holes and you wanted to account for them, you have 2 options. One is to draw an opening where you have them as shapes, and maybe you would also put those on the same layer as the other shapes. And what you can do is, instead of giving this I'm going to take away that tag that shouldn't be there for this shape. Instead of giving this a positive weight, you could give that a negative weight. And what that will do is count that as a whole in our calculation. And then also this wants to make sure that's an area. And you see the weight contribution for that is a negative number, 21.4 kips. You can see down here, this is the weight of our floor, 1858. Let's say I create another hole for another opening, and we see that the number drops to 1836. So that's one way to create openings. Another way to do this is actually, I'll just pull this off to the side for a second. So I'm going to show something that's a sort of a new concept here as part of this review. I'm going to move these two things over off to the side. And what I'm going to do is I'm going to make a hatch. So this is a shape. And let's say I have a big opening in the middle of the shape that happens to be circular, just having a little bit of fun here. And I'm going to use this shape and this shape to make a floor opening with a gigantic hole. So I use the command HB, hatch boundary, right here. Click on that. I tell it what type of hatch to be. I'll make that a solid. And then now at the bottom, it's saying the shapes to fill. So that would be my outer outline. I push enter. Shapes to exclude. That would be my circle. I push enter. And then it asks if I want to delete the boundaries. I will say yes. So that the now I have this new hatch object that was just created. And I'll put that on my layer WU area. And then I can make the boundaries show up so it looks the same as my shape did. But this is now a hatch entity instead of a shape entity. And similar to shape entities, I can give this way up properties. So I would do that. I would set this to W tip floor. And then I can find the weight of this piece this way. Oop, I'm on a different expression system. That was also part of the example before. And I just type entWeight 𝗬𝗶𝗶𝗲𝗁. And so this now has a weight of 1369. If I reduce the whole, then the calculation redoes itself. You can have, say, other shapes that are part of your hatch. Let's say I have this one here, and I want to add that to the hatch. I select the hatch. I start to type add. I always forget what the command is. Add shapes. That's what I want here. I click that. It knows that the hatch entity was selected. Now it's asking for shapes to add, and that's going to be this one. I push enter. It asks whether that's a hole or a fill. I say it's a hole. And it asks again if I want to delete the shape. I say yes. And so now I have these two holes that are part of that hatch. And again, when that changes, the calculation is redone. Okay, so that's how you can add a hole to your way up. And then the other question was, do you have a way of basically getting like a tributary area for a shape if you have, say, like for a column? And I'll show how you can do that. Let's say you have a simple, maybe we'll make it a bit of a complex floor area that you're trying to um, uh, figure out what the tributary areas are. It's just a random thing I made. What you need to do is you have your floor area shape, and then you have a set of points like this. I'm just going to plop in some points in some roughly random locations, but somewhat reasonable from an engineering perspective. Something like this. Maybe that's your column layout. Maybe we need one more in the middle here. And so then what we want to do is we want to mesh this shape and include the points. Sketchulation does have a meshing algorithm built in. That's how it does all its fiber section analysis. And in order to do that, you'll type the command mesh. And you could have holes in your floor to add to the mesh. We're not going to do that for now. So it's asking for holes. I say no. I just push enter for no entities. And then you get this mesh options. Now this is important to pick the right options for this application. The program has options for refining the mesh that you might use, say, for importing into a different program like RISA or something. If you're trying to make a model with a mesh and you want to use Sketchulation's meshing algorithm, you can use it that way. But for these purposes, we want to make sure that there's no refinement being done and that we are not regularizing the mesh. Those two things are the most important things. I'll demonstrate what that does in a second. But when I click OK, it creates a mesh of that outer shape. And the outer shape still exists. You see, when I selected the edge, I still have the outer shape, and I've selected one of these inner mesh entities. So what we want to do next is this trib mesh command, but you want to be careful that you don't grab uh, the outer boundary. We only want to grab the mesh internal piece. The best thing to do if you're trying to get this done is basically select everything, um, and then we want to unselect that outer piece. So how do we do that? We shift and do like this. Now that unselected the outer piece, and we want to go back and just select that last mesh piece. So now I have just my mesh selected, and now I run trib mesh. And what it did was it created a bunch of area or text objects. And so now we can copy those text objects. I'll show how to do that in a second. And these are areas. And the question is, how does it come up with this? It's very important. What it does is it looks at all of the shapes that come into that point, and it takes a quarter of the area if it's a 4-node shape, and a third of the area if it's a 3-node shape. So it's a very simple way of getting a trib. It's not engineering. It doesn't have engineering integrity, so you should be very careful about using this, but it's decent for like a very quick estimate of a column load. So you can do it that way. Now, once we have these text objects, we want to maybe say put them in the table. So what you can do is select everything here. I type MO for modify properties. And I want just the text. So I click text, and I click this filter or funnel, and that leaves only the text selected. Now I go to table view, and I can do a couple things. I can take the location and the text object. So I'll select these columns here, and then I'll hide them. So now I have some areas and some locations, Control C, and then now I can make a table, TBL, and plop in my my location and my area here. So these it thinks that it's text when I inserted it because it has this comma and the IN2. So we want to clean that up a little bit. What I could have done, probably the best thing to do actually is to start over a second. I'll make that not a text column, push Control V. And I see that this is going to come in with a comma that's going to confuse the program. What I'll do is I'll just do a find and replace. So what I see here is that I have numbers that have a comma in them, and I want to get rid of the comma. I want to get rid of the in squared piece. So what I'll do is I'll say I'll use regular expressions here, which is a fancy way of searching. You can look up more about regular expressions in that help button. This is a form that allows you to test regular expressions, and it's a resource for you. Regular expressions are used in a lot of different programming contexts, so you might be familiar with them. But what I notice here is I have some text followed by a comma. So actually, I think looking at this, I have to be careful because if I replace commas, I'm gonna lose that. I'm gonna do this after the fact rather than doing the regular expression check. So I'll leave it. I'll go back to the way that it was. Make sure that the delimiter is tab and not comma. I paste this, and I'll just do my replacing here. So I push Control H. I replace the commas with nothing. So that gets rid of those. And then I don't need these inches squared. I can put those in the column header. So I just copy that, paste it up here. And there was a space too. So I'll get rid of the space. And now I have plain numbers. I need to tell the program this is not a text column. So I can do Control T here. And then this is my area. And we know that that is in inches squared. So I tell the program with the request for value operator to put that in inches squared. And then I have my location P. And then from here on, you can do some work. Maybe if let's say the weight of your floor is 150 PSF, then your axial demand would be 150 PSF times A. And maybe you want to put that in kips like that. And so now you have some column loading that way. I might use this later as a little example for charting, but we'll leave off on that for now. Any questions on the review so far?
It's great.
All right. Thank you so much. Okay, now we are going to get into today's topics, fiber section analysis. So we'll try to do a little bit of a deeper dive than we've done before. There are a couple of example files that you should be aware of in doing this. You can get a concrete column moment rotation or PM diagram, and we even have a retrofit with FRP that you could use, a concrete core wall too. These are all examples that are in there around hollow section, various things for you to look at. I'm going to start from scratch, but do take a look at those examples.
Sorry, quick question, Mike.
Yes.
So that means like the point location or the tributary area is not linked basically to the table. So like if for anything, for instance, if I stretch the
That's correct. No, what
polygon,
you're
yeah,
saying is,
yeah, I have
yeah,
to redo that and like,
yeah.
okay.
Yeah, that's currently the best that you can do.
Okay.
I was trying to think off the top of my head if there are other things. It's on the to-do list to actually do something a little bit better than this, to make more of something that's actually a shell analysis. But we haven't gotten to it yet.
Okay.
Yeah, that's the
Thanks.
best we have for now. Thank you. Okay, so fiber section analysis. This is basically fiber section analysis is a version of concrete section analysis. You know, there's lots of or there's not that many programs actually that do it. And so it's one of the nicest features of Sketchulation is being able to do, you know, arbitrary concrete shapes or any type of hybrid shape or composite shape. Whether it's reinforced concrete, PT, you know, wood with steel, all kinds of possibilities that there are in Sketchulation. So what we want to do is we're just going to do a simple a concrete beam to start with, or a concrete column maybe. And so I'll start by drawing my column using the ccol command here. That's a handy way of drawing columns quickly, and it's usually pretty good. So let's say I have an 8-bar pattern with number 11s, and I click down and I start to draw my column, and maybe that's I don't know, like let's call it a 16 by 24 column. So I type at and then 16 comma 24. And here's my column. Now, right away, we see on the page, it looks way too small. So we're going to adjust our annotation scale accordingly. I'll try 24. That's typically a decent scale for this kind of detail. And I'll move my column over here. Now, a couple things to notice right away. It's still too small. I'm going to go to 16. Okay, a couple things to notice right away is that ccolumn command created some layers. So I'll just show that briefly. In our office, we have some various layers that we use for concrete and rebar. So conc heavy is something when you're cutting through the concrete, you get this heavy line, and you'll see that heavy line has a width of 0.157. You can always bring in the standard layers. It's asking if I want to overwrite what's already existing. I say no. And when I do that, you can see that there are other concrete layers that come in. If I draw a rectangle, I push CLA, and I start to type conc. You see these are the other concrete layers, and let's say I pick a concrete light for this shape. This would be like if you're looking at something in elevation beyond this section or something, and you see this thickness is about half of the concrete heavy. So I just wanted to point that out, that the layering is quite helpful and important. You see the rebar in elevation is the true size of those bars, which we really believe in trying to make sure that you're getting the full visual realization of what you're drawing. And the command is designed to meet the ACI rules with the ties and things, so it should be a reasonably good column to start with. Now, right now, all we've done is basic drafting. It's a fancy drafting thing, so that's kind of nice. But what we want to do is the fiber section analysis. So for our calculation here, I would normally start with a title, concrete column or something. oops, spell it correctly, column, okay. And I put that on my heading like that. And I'll just drag this over. And then we need a concrete strength. You know, typically our F'C for a column, maybe that's about 6 ksi. And then we need our rebar Fy is equal to 60 ksi. Okay. And so from there, we're going to define some materials that we'll assign to these shape entities. So I'm going to bring up the fiber material editor, start to type fiber, or just you could also just type material, and you'll see it right away. And I'm going to make a new material. Okay. So let's just pause a second and take a look at the material. So by default, it's just going to be named material and then followed by a number. And you see there's a drop down here for material type, and the default is generic. So if you have a generic material, you have lots of options. You're going to put in the yield stress and an ultimate stress, ultimate strain, strain at strength loss, and actually you can see there's a little illustration of what those things are in that button there. And so if you're doing a generic material, you need to define these all by yourself and work with that. There's also a pre-strain component. There's a decision you can make about whether it's a symmetric material or if it's positive only. Positive is tension, negative only compression, or it's asymmetrical. So you can do that. You have full control of this. It is a piecewise linear backbone curve, which is usually sufficient for most applications. But you also have the opportunity to use one of the macros that's available. So you see concrete, mild steel, high strength steel, PT strand, et cetera. We get into confined, expected, and expected mild steel and expected strength, high strength steel. All these macros, all that they do is they preset a lot of the backbone curve for you so that you're only having to change one number rather than change all the numbers. So we'll start with our concrete material. And what we built in here is a feature where all you have to enter once it's a concrete material is F'C, and that F'C is an expression. So you can link it up with the rest of your expressions there. So I've already defined F'C outside of the material editor, and so I can reference it here. And I'm working within the global expression system. So that's how it knew where to find that strength of concrete. And so now that I've done that, you see these entries, the inputs are grayed out. You can see what they are, but you can't edit them. There is long-term creep available in the program, and you can look up documentation that ships with the program. It's a PDF file, so you can see how that's done. We're basically following the ACI standard for long-term creep, but this is the background calculation here. This is good for calculating structural long-term deflections in a structural analysis, which we're not going to get to today, but maybe in the future we'll have time to do that. So I have my concrete material. I need to assign it to this shape. So what I can do, a couple ways to do that. I can select this guy first and click the paintbrush and assign here. And now that concrete material, that shape has a concrete material. I could have done that here in the modify properties editor. I can select the shape, and then you'll see that there is a fiber material entry. It's already set up as that F'C that I already did the paintbrush and assigned it. Okay, so my shape is now defined, and now I want to create a mild steel material. I go here, mild steel, and same thing. There's just this expression here. I use Fy, which is defined outside the program, and then I select this material. I click the paintbrush, and I select all my rebar like that. If I want to just be sure that I selected the things properly, I override layer colors, and I see that the bars are orange and the outline is red. You see these guys, the ties don't interact at all with the analysis. So that's set. One last thing, you can take a look at the graph of these backbone curves. So you see here's my concrete, and there's the concrete with creep there dashed in. And then this would be my rebar. And then this would be both of them on top of each other. Any questions about the fiber materials? Okay. Now that I have a cross section here, it's got the definitions I need in order to do fiber section analysis. So the rest is a little bit of a question like what do you want to get out of this analysis? For example, maybe I want a PM diagram. I can type PM, and that is one of the commands, PM, fiber section PM. When I click this, it brings up this is a fiber section analysis form. And this is an interactive form where you can really study a cross section in depth. So if I click on the graph, I can see the cross section state on the top right. And how it is responding to a certain level of moment and axial demand. You see I'm plotting right now unreduced capacity, that's the outer line, and then the reduced capacity is the inner line, which is with all phi factors. Now, every point that I click, you get this nice contour of stresses on the cross section. And then you can also click on a particular fiber, and you can see information about what's going on with that fiber down here. I can show the graph of what that fiber is doing on the material stress strain curve. I can click a rebar and it shows me the same thing here. I see, interestingly, at that location that on the PM diagram, this rebar is not even yielding. So it's in tension, but it's not yielding, which is good to know. Like we go, say, near the nose of the PM diagram, that is the definition when the rebar starts to yield in tension. So that's your maximum moment condition. And then we can also, there are other features here that you can do with the cross section to kind of see how the moment in the cross section and shear in the cross section, the shear flow is being resolved. And then you can see the contributions of the various fibers as a cross section through that. It's a cross section through the cross section, I guess, or a line through the cross section perpendicular to the bending moment axis. If you wanted to do other analyses, you can do more with this. You go to the analysis tab and you can change the number of points. Right now, the phi factor is auto. That means it's going to try to discern if this is a concrete section, and if it is, it's going to follow the ACI rules based on essentially the proportion of concrete material to steel material. You can add other moment axis angles. So I can click 90 degrees, or maybe I want a 45-degree PM diagram. And then I can click Analyze. And then I get a whole bunch of PM diagrams all on top of each other, and it's a little overwhelming. So I'll get rid of the unreduced capacity. And you see I have 3 graphs. So this is my 45-degree PM diagram. I can push the arrow keys. This is arrow left and right, and I can go up and down on the PM diagram and see how that's working. And then this would be my PM diagram along the 90-degree axis, like that. Any chart like this you can export. So I can right click, I can export an image. I can save the XY data or at both X comma Y or X or Y. I can put the image in the clipboard. I oftentimes I'll take this data out as XY data and I'll put it in a table in Sketchulation to save the state. You can select graphs and isolate them or show them all or turn off the legend. So all those features, whenever you see a graph, all those features are available to you. Are there other types of analyses available in this form? We can say do a moment rotation. So that's the moment rotation curve, and you can see that this is a moment rotation curve with 0 axial load. I can go back here, and there are other features here. I can do say a 90-degree moment rotation curve, and then I can put in some axial demand and analyze all that. And so these are all my moment rotation curves for those various conditions. And you see this one up here with the axial load is got a higher moment, but then you see it's a more brittle column. It comes down, a more brittle response, starts to crush the concrete. And you can see that here if we do the fiber material curve, and as I move along, you see the dot on the bottom right. It's the concrete is creeping up, and then eventually it's losing strength, and we start to crush, and you see the neutral axis move back. And lastly, there is a moment curve, so you can see the moment. I like to do this just for fun. Spin that thing around and see how the moment response changes based on moment angle. Any questions on the fiber section analysis form here? No? Okay. Now the fiber section analysis form is
sorry, Mike, a quick
yes,
question here. Sorry.
yes,
So this is like an individual window. It doesn't show on the page, right? So
that's correct.
okay.
Yeah. Yeah, that's kind of where I was going. Did you have a follow-up question on that?
No, no.
Yeah. So this is very nice for in-depth study of a cross section. You can take screenshots of this. I can also watch this. I can click this thing. Uh, uh, Click to pick point. What I don't know that this is, I believe, is going to make the mesh, the colors appear. Yeah, I think that label was wrong. So I'll have to go and look at that label. That didn't make any sense. But what it was supposed to do is what it is what you see here is that it created a color map of that particular state, and it created a layer to do that. So I can isolate that layer, and if I don't want to see it anymore, if I want to move it off, I can go like this, move it off to the side, turn anything back on. So you can save states like that. You can copy and paste like the data from the charts and stuff. So those are some ways you can use this and get it back in your calculation, but by itself, it's not live. So it's limited in that sense. And so to extend the functionality here of the program, we have a number of possibilities here. So one of the things we can do is we can create the PM diagram through an expression. So I can type xt and I can type PM is equal to, we say get PM, and it's now asking for a cross-section boundary. I forgot to tag this, so we would need to create a tag here. I have a shortcut command tg that is going to set the property of that thing. I'm not sure if I've gone over that before, but you can create your own custom commands here, and here's the one that I was just referring to. This is an assign property type custom command. This is the shortcut for it, and this is the name of the property that I'm going to assign. And there are some help buttons to help out with that. So I'm going to assign a tag here, tg, and I'll call this column 1, because I'm probably going to make a column 2. Maybe I'll put an underscore there. And usually I put an XS at the front to differentiate it from sort of other symbols. So like that. So here's my column 1. And now if I want the PM diagram, I push XS call 1. And when I display the result, it comes out like this. So here's my PM diagram as an array. Sketchulation does have arrays, and they work with units, and you can do all kinds of any of the things you're normally used to doing with matrices. You can do in Sketchulation with arrays. But so here's my PM diagram. What it did was a fiber section analysis of this cross section, just like it did in the form, but it does it behind the scenes. And so you can work with the data this way. Now, let's say that's useful, but I might want to graph that. So I can graph that in a chart. I'll make a chart CHT, and I'll draw it off like this. And then I'll type SCR to make a series. And I go in here. I want an expression. Okay. Oh, no, I want vectors actually. So this is 2 columns of data in an array. So that's usually with the vectors. I could do it with an expression. I could directly enter getPM into my expressions, but since I already have the data in an array, I'll do it this way. I hit the checkbox that says X expression yields XY pairs, and I simply type PM. Oops, lost the focus there. PM. And so it's looking through the expression system to find the data or the symbol I'm looking for. I have it there. I click add, and there's my PM diagram. It's upside down from what we're normally used to seeing. That's just how we structural engineers like to roll. So I need to reverse. One of the properties of the chart is to reverse the axis numbers. So we do that for the y-axis. Say yes. And so that is my PM diagram for that column, the same as we would have gotten from the PM editor. Now, if I want 𝗲PM, I do a copy expression CX1. I put tilde F 𝗲PM, and then there is another function, get 𝗲PM of that same column. I can go back here, type SCR again, and put this at the front, 𝗲PM, like that. Add, and now I have my 𝗲PM diagram. So this is a nice one-off. I've drawn my cross section. You could imagine that this could live in a column schedule. We can turn off this tag if we don't want it to display. I believe it's called display tag. We say no. And so then this could go in your you could set these up as a column schedule and make them, you can print them off directly for your drawings, or you could export to a DXF file and put them in AutoCAD if that's how you work, however you like to do it. And now let's say we have multiple columns, because we always have multiple columns in a building. And I'll go back and I'll push enter to display that tag again. Oops, lost the command. Display tag. Yes. Okay, so that's there. Now let's say you have another column. We'll do the ccol command again. And this one, let's say this one is 16 by 16, no, I'll make it 18 by 18. 16 by 16 is kind of small. I type the at 18 by 18. So this is a smaller column. And then let's say these bars are smaller. I select them, I type bar size, and let's say these are 9s, they're smaller. And so then now I just need to assign my materials again to this here. And then my rebar. Okay, and then I always double check just to make sure it's good. I tag this guy. Now you might, after your 5th or 6th column, you might get tired of tagging these things. So I'll show you, you can actually do an auto tag. You have many things to tag all at once. You do on auto tag, we say xsCol, and then underscore is my little prefix. And then we want to start with 1, and that will auto tag my columns in the order that I choose. It's just telling me that I replaced it, and that's fine. So now I auto tag these guys. I now have 2 columns to work with, and I'd like to get all of my PM diagrams to land on the same chart. So I'm going to make a table, and I'm going to make a column in that table, call it TG for tag. And this is going to be a text column, okay? So I push Control T here, and I have xsCol underscore 1, like that. And then I have xsCol underscore 2. Now, if I had 3, 4, I can grab this just like in Excel and pull this down like that, and it numbers them off like that. And I want to make this look nice, so I right click and I say render text as a math expression, so that looks like that. And now my PM diagram, I can actually define this function outside the table. Instead of this, I want TG, and instead of that, I want TG. And so now inside the table, I just type PM, and we get all the data right there in the cell, and say 𝗲PM, and all the data is right there in the cell, and we don't like to see that really, so we select a table and we type this command that says render arrays compact. We want to say yes, so that we know there's data in there, but we don't need to see all the numbers. Unless you wanted to, you could look at it carefully. Now I got question marks here because this is no longer these series don't know what to do anymore. They're not defined outside the table. But I will show how we can go ahead and plot these PM diagrams, and as many as you have, you can plot them all in one chart. I go in here, I'm going to edit the series, EDS. I will delete these 2 series because I don't want them anymore. And now I will select, I'll make a new series. And here what we're going to do is a very special type of plotting table cells. So this is what the program thinks we're doing, is that we're going to have XY data within a cell of the table, and that's exactly the way we've set it up. So that's perfect. We're going to tell the program what's the column with the name in it, and we'll just leave that as the TG column, and then the column with the X, Y pairs. And then you can put a filter expression if you don't want to plot them all at once. So we delete that. So we're set up to plot everything on that chart. And so now we've got both our PM diagrams in there. And just for fun, maybe I have one more column. ccol. Let's say this one really well. Let's do something fun, like a circular column, and that's an 18 inch round. We don't have a fancy function for that, but I'll make a rebar rbsect. And maybe these guys are not, I'll do number 8 bars just for variety. Number 8 bars. I put that on, I'm going to offset it from the edge. So I shift, right click, base point right here, and then Q for quadrant right there. And I'm going to come in, say 3 inches. Now I'm going to array this bar, AR. There's 3 different types of arrays: a linear array, rectangular, and we want the polar one. And so we have some choices here. We want, say, quantity plus angular extents. So the quantity, let's say we're going to have, I always get this wrong when I first do it. We're going to have, it's saying the number of copies, but we're going to do a 360 degree. And I think we want to omit the last one. My base point is the center of the circle. And I just array these guys around like that. And in the end, I want 360. And so now I have 9 number 8 bars. I need to assign my materials here, my rebar here, double check, make sure everything looks good. I want this to be on the concrete layer. So I'll put that like that. Ooh, and I don't want that tag. I want this tag to be xcol 3, like that. No, we don't want to change all those. Okay, so now I have a new column. Simply need to add a new row. And here I can use my fancy thing to not have to type so much. And there we go. Now we have all our PM diagrams all on the plot like that. Now at some point you're kind of got all your columns. You group these all together on your worksheet, and you're sort of ready to print your calculation like that. Any questions?
So you wanted to use a different number of rebar. Is that pretty easy to change, or would you have to redraw the array?
If you wanted a different size, it's really easy. If you want a different pattern, then you have to redo the array. Yeah.
Got it. Thanks.
This does bring up another point, though. This is fiber section analysis for these particular cross sections, and these cross sections could be arbitrary shapes. So you can it's very flexible that way. But if you're schematic design, you don't want to have to spend all that time. You can do something even better. So maybe I'll make another table here, and this is the fastest way to make a PM diagram. So what we will use is we'll have 𝗲𝗶𝗹 in this table, and we'll use the getCol 𝗲𝗶𝗹 function. Okay, so this circumvents all the drawing and stuff. This is really for schematic design, and it takes a couple of different inputs. There's 4 versions of the function, but two of them are really the main ones. There's a round column option or a rectangular column option. And so let's say we're gonna, if I had a round column and I didn't, schematic design, didn't want to draw it all up, I would look at these inputs and I'd say, okay, I need a diameter and a row value. Everything else is kind of predefined. So what I'll do here, I'll leave that function for a second. I'm going to have my diameter, and then I'll put that in inches. I'll enter those in a second. And then I need a row steel ratio. And so, maybe I have a couple of these, 2%, 3%. And then let's say I have a few different column types. We'll have, say, 16, 18, 24. And what I'll do is I have sets of 3 of those, and then that's a set of 2. So I'm going to duplicate these guys. That's down here at F9 key, duplicate cells. And I want 3 duplicates, 3. And then I just Control C, copy those, and Control V, paste them here. So now I have what I need in order to do a column PM diagram inside this table. So I'm going to fill this out. My diameter is D. My row is just what's entered there in the table. Fy is defined outside the table. F prime C is defined outside the table. And then my cover to the rebar, call that 2.5 inches. Like that. And so then it generates the PM diagrams for these round columns. And then again, I render the arrays compact so that they're all inside there. And then we can create our PM diagrams from that table. It's going to get pretty crowded here in a second. Table cells, table 2. And here we have the name. We'll just use the D and phi-PM just like that. And these are half diagrams by default when you're doing a column PM diagram. So they're all symmetric columns. That's why there's no point in doing a full diagram. So that's the quickest, fastest way of generating a column PM diagram that I think there is.
Nice.
Yeah.
We have 9 more minutes, Mike.
Okay. Pause there for a second. Any questions on that?
So
okay. Oh yeah.
just one quick question. So the stirrups shown is just like for visual, or like there's actually some function to check shear and stuff like that?
They're visual here. And you can do things with them. Like I can get the amount of rebar in here. That's kind of one of the things we'll do is we'll draw this up. We'll try to give an estimate of the tonnage. So you can query this shape. It has a tag, and you can get the weight. Each of these has a weight associated with it. And in an expression, you can sum that all up. So in a table exercise, I could assign this column a length. I can get the weight of my ties in here, and then knowing the spacing, I can estimate that. So that's kind of, those are some of the things that we use it for. When we get into structural analysis using fiber sections, you create a frame element type from the tagged shape. So for example, I could tag this here, and then it pulls it in. You see, it doesn't pull in the shear reinforcement. So here's where you don't get a connection between the shear reinforcement. It's maybe something we could add in the future, but it's a little tricky. But here's where you would want to make sure that these things match up. So that would be set your spacing, set your stirrup size, and then number of legs. So 2 in this case in one direction. Yeah. Thanks. Any other questions?
No, thank you.
Great. Okay, we're gonna just do a little bit more on the features of graphing in the last 7 minutes here. So we've made a bunch of series here. It might be good to it might be good to separate this out. There's a lot of data all in one chart. So one of the features in Sketchulation is to be able to edit multiple series on multiple charts all at once. So I copied the chart over, and now I'll do some editing. Edit series. And you see these are the first thing I might want to do is I might want to in this one I don't want these sections, for example. I get rid of those, and so now I have my half diagrams from those round sections that were generated here in this column. So that in this table rather. So there's 6 of them there, and in this one, let's say I get rid of these ones. I don't want those. And so they're differentiated in that way. Maybe I'd like the round column to be a different color and marker style than the others. Maybe I want them to all be the same hue or whatnot. There are lots of ways to organize these things. So if I just focus on this chart for a second, let's pull down some of these menus. The name here is right now it's got this tag in it, this carrots and then the C, and that tells the program to indicate the name column. So there are various tags that you can use, and I thought I had a help button there. We're going to add that. But things like F for filter, X if there's if you have a table column series, you can give the name of the column, the X column or whatnot. Or you can just put in, literal text, whatever you want. Call, let's say, I do like that. And you see it changes the legend, changes all of these all at once. They all have the exact same name. Now, if I want to change the hue of all these to make them match the hue, I can make them all blue like I prefer, like that. Now, maybe I want these to do some sort of gradient. I can right click on them and I can do an auto format selected series like that. And I can decide if I want a marker style. And then maybe I like a gradient. So we go from one color scheme, maybe a light one, to sort of a dark one like that. And when I click OK, there's a bunch of other options that you can look at. And so that does a gradient where these guys are getting dark. They're dark to start with and then getting light as you go out. Maybe I want to have them have different markers, so I could click enumerate markers like that, and then that separates them out with different markers. Now what those things are doing is basically affecting the saturation or the lightness, luminance of these things. I could select them all and give them the same luminance. So that would be a way of making them a little bit faded. Or I could change the transparency of them all, and that will the alpha component changes that. Various features in that regard. You can do things where you do histograms. These will look silly with a PM diagram, but there are histograms and steps and things like that that are useful for other contexts. You can fade or basically hide or fade out a series if you're not interested in seeing it for a second. Can bring it back. Various other features. What I wanted to just show here is that you can change the thickness of the line. Here, different dash styles are available in the drop down there. There you have the markers, so you can select different markers, change the marker size. You can tell it whether you want the markers evenly spaced or maybe just in particular places. Maybe you want them at the extrema, so they do mark the series, but not on every single point, so it's dominating. And then one thing I really wanted to touch on here was the point labels. So you can do lots with point labels. There is lots of description here about what those labels do. And basically you can put in special tags that will change what's actually reported in the label. But maybe one example might be that we want to know the maximum moment. So we could put, say, X here. That's going to give us the X coordinate at various points. And we have to tell it whether we want that to be evenly spaced or in this case, we want actually the maximum X value. And so this is maximum absolute. So you can see these are the maximum points on each of those curves for X. Or maybe we prefer to see the X comma Y. Oops. Meant to do this Y like that. And again, now it's giving me the moment and the axial force. And then maybe I want to put those at the extrema like that. And by default, the thing is rotated, but you can give it whatever sort of angle you want. And there's an auto angle feature where it sort of follows along the curve and spins it around, but I typically just leave it like that. Okay, that's a brief touch, a little briefer than I wanted. There are some other things that we'll want to do with graphing that's really important for like large data sets and things, but this fit nicely with the context of columns and PM diagrams and things like that. Any last closing questions or thoughts before we wrap up? Okay. Well, thank you very much for your time. Always feel free to email me or Natalie with questions. We'd love to hear from you. And yeah, we'll be emailing for a part 4 pretty soon here. And just want to thank you for your time and your interest. All right.
Thanks, Mike. And thanks, Mohammed, for being so interactive.
No, thank you.
See you guys next time.
Bye now.
Thanks, bye.